Hi guys, my name's Kevin Paroda.
And I'm Justin Keenan.
We're here from Mobium Solutions, where we've developed an add-on for 3D printers that lets you print multiple things in a row without ever needing to return to your machine. In developing this device, we make use of several physical properties that help us achieve our goal. In today's video, we're going to demonstrate a science lesson to explain these properties and relate them back to how our device actually works.
You're going to need a water bottle, a scale,
a thin, smooth sheet of plastic material. This is PVC, but you can use any type of plastic material. And a sheet of a larger material. This is aluminum, but plastic will also work for this as well. And you can pick up these materials at a local home improvement store for a low cost.
So to start out, we're going to talk a little bit about friction. Friction is something that affects our everyday life, from walking to driving to skating on an ice arena. All of these things come into effect when you have two different materials coming and colliding. Those roughness or the fineness of that material determines how much friction you get. So here we have our PVC material and our aluminum material. To demonstrate the amount of dynamic and static friction, we're able to slowly move our scale and pull the material across the substrate. Now, to demonstrate the adhesion between the material and our aluminum substrate, we're able to take a little bit of water. This water acts as our vacuum. By just spreading a little bit of water across the aluminum plate and taking our PVC material and putting it on top of the water, then smoothing the surface out and getting rid of any air bubbles that might occur. By applying the water, we're able to get these two materials very close together. And by removing all of the air, we can simulate what it would be like to have a vacuum table and to put the material on top of the vacuum table. Now we can demonstrate how much force it takes to break that adhesion force between the two materials. By grabbing our force scale and measuring how much force it takes in order to begin moving, we notice that it's significantly higher than what it was without the water between the two materials. That's because of the adhesion force between them. Now, something we do in our product is to mitigate that adhesion force is we lift it up at a vertical angle. By lifting it up, we're actually able to peel it away. So instead of going directly parallel, we can have a little bit of perpendicular force, and it's much easier to peel the two surfaces away than it is to actually try to slide them up against each other based on that friction and cohesion. Here you can notice that it's almost no force to pull it up at a vertical angle.
We apply these concepts in several places in our device. First, during the printing process, as Justin stated, we use the vacuum to adhere the plastic sheet down to the aluminum vacuum plate. This provides a very stable surface for printing because the two surfaces are held together with a lot of force. Once the print is finished and we need to remove it from the printer, we first disengage the vacuum and then pull the plastic sheet upward at an angle of 10 degrees. This helps break the adhesion between the two surfaces and lets us remove the sheet with the print still on it successfully every single time. Understanding these forces was key to us in building a device that was reliable, and we hope that in this demonstration, you'll be able to express these forces to your students as well. Thanks for watching.